Good morning, lady and gentlemen. Thank you, Professor Mastorakis, for the option to present these things. I think that here I am Javier Bilbao from the University of the Basque Country, and Imanol Bilbao is the same surname, but it's not because it's like Smith in the States. Bilbao is very common surname in my city. So, but this is my uh, former doctorate because he is now a doctor with a part of this presentation was in his thesis. So, and this is very good option to present these results and so on. So here I will focus on only two methods of machine learning, linear discriminant analysis, LDA, and KNN techniques, two recommendation systems. I will explain now. My university, the University of the Basque Country, is in the north of Spain. It's the unique public university with almost 50,000 students. So I will start with the introduction. Okay, a little bit of mathematics, not too much after the previous dense presentation and good presentation. Mathematics is okay in almost all engineering subjects, and is fundamental for engineering education and so on. So at the same time, the present skill set for undergraduates and also for master students is to apply the ICT new methods, technology, and so on. And I will start with a previous method applied in our machine learning techniques for recommendation. And this is known, so I will be only two slides. Principal component analysis, PCA. That this is unsupervised learning, or is categorized in this side of the learnings. Based on some of the characteristics, the whole characteristics of a data set, these techniques allow to create a new set of characteristics from the previous one, but smaller in number, normally 3, 4, 5 characteristics, and therefore easier to manage and to represent, also to contrast and so on. To achieve these objectives, to reduce the principal characteristics of our data set, normally a linear transformation is used, and then select the smaller number of those characteristics, but without, or this is the all people try to do, without losing important information for the study. This will be important in our study because we will have almost 100 characteristics in our different characteristics in our data set. The final objectives of this techniques is to find mathematically an orthogonal matrix that allows this change of characteristics, this reduction of characteristics from the original one to the new set of data. Okay, the variance captured by each component in this matrix is represented by the eigenvalue associated with obviously each eigenvector. We have used different classifiers, the techniques from machine learning. This is the list of the classifiers or techniques that we have used. And we have used as I think, as usual, MATLAB. But here we only will speak about LDA and KNN. Okay, classifiers for what or which is this? The mission of one classifier is to correctly, obviously, assign data represented by a vector of characteristics to one of C, in general, different categories, which have previously been defined by the researchers. And why viewing the characteristics of our dataset. Most machine learning techniques search for and assign the category to which the lowest risk is associated in the event that an error occurs. That is, if the error is the smallest one, in general, for people, this is a good technique. Yes? And a little bit of mathematics, that is, for a certain data X, the techniques in general first calculate the risk of consequences of making a wrong decision by wrongly selecting the category using this expression. That is, if we, and I will speak about a wine recommendation. We have a data set of a wine from a region of Spain. Yes, and the idea was to recommend it to some user, to some customer, which wine he will like better than other, but without tasting it. Yes, and why? Because we have several data sets from some tasters and from previous taste from this user. So we try to extract the principal characteristics of the wines for each user. Yes, so this is our categories and our data. Okay, first one technique, LDA. This is usually used to classify each of the samples with the assumption that the probability distribution is multivariate Gaussian. Okay, and that the same covariance matrix is the same for all distribution of the different classes. The decision is made according to the so-called Fisher discriminant function. The problem is that sometimes there is not a distribution like a multivariate Gaussian. But here are some results. In the event that we have standard losses, the decision limits obtained using the technique are the hyperplanes equidistant from the centers of the different classes. In this figure, decision regions of this classifier, LDA, not validate in the first two independent Fisher principal components of the data of the first taster. We can see that it's not a bad classification, but if I will go to buy to a supermarket some wine, oh, I wrong the wine. This is not possible result for our system. The other method, KNN. This algorithm is a simple algorithm, conceptually, algorithm that falls under the category of supervised learning. So we need previous data. It's often used for classification, and using this algorithm, the decision ranges that separate each class can be constructed without first needing to estimate the density function. So the calculation time is better. To build this decision of classification regions, all the training cases provided are saved by the algorithm to later compare the distance between Euclidean or Manhattan distance we have used between the new sample that we want to classify and each every one of the training cases. Thus, the algorithm obtains an ordering with the key nearest neighbors. The number of these neighbors to choose and the metrics used to measure distance are the parameters in the design. The choice of the most favorable option, the distance metrics, in our case, can be Euclidean and Manhattan distance. Subsequently, we reserve a sample to test the classifiers used ALOLO, because we have not a big number of data set. We reserve one to validate the classifier and select the number of neighbors. The rest of the samples obviously will be used for training. And here we have another figure with results of this other method, KNN. The decision regions, in general, where is the classification of the data, are different depending on whether Euclidean distance classifiers are used, or if we have used the Manhattan distance. So the metric is important in these things. Using the first two class-independent Fisher principal components for K4, along with the Manhattan distance, this is for the Manhattan distance, we obtain this classification range. Okay, and some conclusions. In this article, the data set that we are comparing are from wines from Rioja, that is a region of Spain. The novelty focus on the applicability and also on the results of these techniques, comparing the results of techniques with each of these techniques of the same data for wine, that there is very small quantity of data set for this classic drink. Furthermore, it has been demonstrated that 4 factors are sufficient to characterize the wines. And I don't say before, but we started from almost 100 different characteristics of the wines, taking from chemical analysis from the wine, taking from different tasters, professional tasters for wines and so on, with the aim of creating a recommendation system like for each user. These factors have been anthocyanin derivative, is a characteristic of red wines, alcoholic content, tannins, and other wine characteristics, and anthocyanins directly. And finally, if we take into account the representation spaces of the sample, the regions, and so on, there is no significant advantage in the classifiers if we apply the PCA technique on the original data. Furthermore, it doesn't improve the classification results if the PCA technique is applied before the Fisher decomposition. And these classifiers of techniques, LDA and KNN, can be useful in the recommendation system. I have here, because okay, I think that I have time, another conclusion that I think that is important, at least from the mathematical point of view, that how to say, both classifiers, LDA and KNN, can be useful in the recommendation system, but they are not in the techniques classification before other machine learning techniques, like for example the use of neural networks. We have tried also neural networks, and they give a good result, but in this case, for example, in the case of a neural network, they need more time to the calculation and so on. But from the point of view of the user, all of them are okay or similar for the results. And this is all. Thank you for the attention.